The server is a finite state machine handling all the interactions with the AI block and the player block, which handles all the input from the player. The different operations are shuffling, done through a linear feedback shift register, as well as giving cards to player and AI, and computing points at the end of the hand. The player has other characteristics because it must manage the input from switches and buttons, and thus also manage the debouncing of the buttons themselves. It also manages the delay between the different components, which was a critical point in the design of all the game. It also manages the reset, because when it is sent by the player, it is received by the server, which resets all the cards and the game itself.
The artificial intelligence block is in charge of acting as a real opponent and thus replying to the player's choices. Since it mimics the behavior of a real player, it needs some place to store the cards in. For this reason, the artificial intelligence has got a card manager block, which stores the cards and resembles a player's hand. Second, we need something to decide which is the best card to be played, and this is where the actual intelligence comes out. For that we have a new functional block, the card chooser. Using information about the game and receiving the ending input from the card manager, it selects among the three possible choices. By changing its algorithm of choice, it is able to switch among two possible game difficulties, easy and hard mode, in which of course computations are longer and take into account many more situations and possibilities. After a choice has been made, the played card is sent to the server for score computations and video updates.
For the FPGA interface we have two output, 4 bits for each color, and we had 3 color RGB. Also, we have to output two signal, horizontal synchronization and vertical synchronization. Horizontal synchronization must go low in order to start a line, while vertical synchronization must go low in order to start a frame. Before and after each synchronization pulse, the RGB signals should also go low for a specific number of clock cycles in order to create the front porch and the back porch. The fixed clock for 6040 x 48 at 60 Hz is 25.175 MHz. So we used a PLL to generate it from a 100 MHz clock obtained from the oscillator on the board. The FPGA sync block manages the positioning of the FPGA cursor through counters and pass the horizontal and vertical cursors to the next block, which is called FPGA drawer. Based on where you are on the screen and the parameters given from the server regarding the current game, this module communicates with the memory in order to request the images needed. Finally, the FPGA block outputs the colors of the pixel that is displaying on the screen. The board has a mono audio jack output, and the audio block uses the PWM technique in order to output a signal for each note.
To construct a theme, we stored in an array the constant needed for our implementation. Those numbers are evaluated from the frequency and the duration of each single note.